Hey folks, how's it going? People keep asking me for help on 10.2 number 15, and when I talked to them, they said they got through 7 through 11 no problem, which means you totally understand the standard 6 questions and you can solve a hypothesis test. So if you can do 7 through 11, you understand the game. And then problem number 15, they start using words to confuse you. So when we look at problem number 16, read the problem a few times. So they mention Nate Silver's book, The Signal and the Noise. 733 predictions, 338 were mostly true. So that's actually part A. So part A, the question is asking us to figure out the p hat. So part A, they just want the p hat. So the p hat happens to be the bigger number on bottom, 733, 338 on top, 338. Okay. And then they say, question B. So that was part A, determine the sample proportion, which is p hat. Part B, suppose we want to know whether the evidence suggests the political predictions were mostly true less than half the time. State the null and alternative. State the null and alternative. So at this point, we know that the null should look like this. P is equal to something, and then P is either greater than or less than or different than, and then whatever number went in the null also goes into the alternative. And they didn't straight up tell us a number, which is confusing. So they're probably using words to trick us. Less than half the time. So part B says less than half the time. So less than half. Aha. Okay, so there's our null and our alternative. And we have our p hat. So in theory, we could just throw this all into our calculator right now and sort of finish off the problem. So let's just do that. My calculator. Oy vey. Okay, we'll turn it on. Stat. Whoops. Tests. One prop. Z test. P of 0.5. Oh, did I do this already? I did. P hat. Or 338 and 733. Choose the less than symbol because that's what's in our alternative. Calculate. Okay, so that gives us a test stat value. So see, no one really asked for the test stat value, but let me just write it down. I'll round it, so negative z is equal to negative 2.11. Round it to the hundredths place. P-value 0.0176. Right below that is p hat 0.46111. So that's this number. So this value, this p hat that we just figured out, is 0.4611 approximately. So when we wrote it out, the calculator also figures it out for us. And then if you sneak down and read the problem a little bit more, in part G, we're doing problem number 16, they randomly tell us that they want the alpha, the significance level, to be equal to 0.1. I usually call it 0.10. So that way I can see that my p-value is less than my alpha. So if your p-val is less than your alpha, you would reject HO. And if you reject HO, then that means evidence suggests the HA. The proportion is less than 0.5. And then let's try and use the words they use. So evidence suggests, I'm just going to pretty much write what they're, evidence suggests the political predictions, just sort of copying down part B, were mostly true oy vey, less than half the time. Okay. So what did we skip over? We still have to do, let's see, we have part A up here, part B. We skipped over C and D. So question C, there might be a little bit of room right here. Question C. Question C is just asking about the verify the normal model may be used. So minimum requirements. So all we need to do is make sure that n times p naught 1 minus p naught is greater than or equal to 10. So if we plug those in, n is 733. P naught is the p mentioned in the h naught, 0.5, 0.5, 1 minus 0.5. And if I throw that into my calculator on clear, 733 times 0.5 times 1 minus 0.5 is also 0.5. 183.25, which is greater than or equal to 10. So that checks out. And then technically speaking, we need to make sure that sample size little n is less than 5% of the total population, capital N. And that seems like that seems reasonable since we're talking about Nate Silver and we're only looking at 733 of his predictions and he does so many, it's probably way more than that. So the 733 is probably way less than 5% of all the predictions he's ever made. So it seems fine. Part D, it's part C. This is getting a little sloppy. Extra piece of paper? Sure. So part D. Part D, we could put it down here. Part D is just asking for draw a normal model with the area representing the p-value shaded. Okay, so you just draw a bell curve. And then it's a left tail. See how our alternative is pointing to the left? So shade on the left side, and the area that we shade is the p-value, 0.0176. So the p-value is just the area shaded on the left side. So we have part A, part B, C, D, E, F, and then G. So F is kind of a silly question. F, they're trying to help you. There's nothing worse than someone trying to help you. It says interpret the p-value. Interpret the p-value. So here's how I would interpret the p-value. And I'll tell you what the book says. So I would say the null is what we're assuming to be true. Okay. So if we assume this to be true, what's the probability of our experiment or what we witnessed? So what's the probability of getting this 338 out of 733 or something more extreme due to chance? Oh, the probability of that is 0.0176. Okay, so it seems that that's kind of a low probability. So it's probably not just due to chance or something probably going on. So what we would do is we would reject the HO like we did, and then therefore we say evidence suggests this like we did here. That's how I would say it. So basically, once again, what's the p-value? Assuming the null hypothesis is true, what's the probability of what we witnessed or something more extreme? That's our p-value. So almost the same idea, but rather than just using probabilities, they said if you were to do this 100 times, we would be expecting, so then they multiply the p-value by 100. This is what the book does, super annoying. And they'd say, oh, so 1.76, about 2 times it would happen. And then you would say, oh, 2 times out of 100, that's not a lot. That seems kind of weird. I should probably reject the null. Okay, so if you look at your answer for 15F, that's kind of what they did, was they multiplied this value by 100. So rather than just thinking of it as a probability, they sort of over-explained what a probability was. Okay, so once again, we basically know the game. So when you get to these word problems, just read them carefully. You'll figure it out. Hope that made sense, folks.